So the mean. The mean is simply another word for the average. And the average, what we're looking for to find the average, we're finding the sum of all values, we can say all values of x in a sample divided by the sample size. And we can pretty much calculate the average, I would think, but this is the technical way of doing such things. When it's useful anytime you're trying to give an estimate of the center. We call these measures of central tendency. So the average, the mean is a measure, something you could measure for a set of data, and it's useful when you're trying to predict a typical value. It's it's shooting for the middle, the average, and usually it's best when the data is symmetrical. So symmetry is sort of the key to a lot of these. And so when you're looking at the average, if it's symmetrical, most of the time that'll be the case. We'll look at a situation where that's actually not the case later on. Median. The median is also a measure of center. However, the median is just the middle term. Okay, so here you're looking at all of the data. And data is basically a word that describes all of the individual items within a sample. Okay, so all of the data is used to calculate the average. The middle term is really only one or two terms in a set of data. Okay, so when the middle term is useful, if you're trying to predict kind of the central, a typical value if data is skewed. Skewed data, when data is skewed. Now I'll show you a couple pieces of skewed data. If you've got a lot of data here that trails off to the right side, this is called skewed right. Okay, people have a tendency to think this is skewed left because most of the data is here, but the skew means it's kind of pulling in one direction. Okay, so skewed left would have a big tail this way and then it would stop abruptly there. This is skewed left. Okay, so skewed right and skewed left. The reason the median is better, is a better estimate of that, is the median is going to be kind of close to the highest point here. The mean, because there are larger values over here, the mean is going to be drawn to the right. So if you calculate the mean and the median, you find that the median is higher than the mean, you'll know that that data is skewed right. Same thing here. The median is going to be right about there. That's the median. And the mean is going to be over here because there are lower values here that are pulling the mean this way. Mean. Okay. Now when I say one or two terms, and we'll look at that with this specific example here, but the middle term is basically arranged in order. Now, when you arrange this data in order, and I'll show you this example here, we'll do it really quickly here. 2, 3, 4, 6, 10, 14. Okay, you add all that stuff up, and we'll let you do this one because it's kind of easy. I want to show you this one though. There's 6 pieces of data here, and when there's 6, that's an even number. Okay, so when you look at an even number, there is no middle term. The middle is right between the 6 and the 4. So to find the median, you find the average of the middle two. Okay, so if there are 2 items, or I'm sorry, if it's an even number, so if a sample, and I'm sorry, I'm all over the place right now. That's the sample size, and we're gonna calculate the average here in a little bit. But when you divide by the sample size, if n is even, then you find the average of the middle 2 terms to find the median. Okay, and so we'll calculate, well, right here. The median of this one right here is going to be the average of 4 and 6. And if you're only adding the 2 of them up, it's 4 plus 6, which is 10, divided by 2. So the median is 5. And that might seem strange. If you're looking for the middle term and 5 isn't even a term in the set, you're still looking at it as a measure of the center. And so it's close enough to the center. And while we're at it, if we add all this stuff together, that's 5 and 9 and 15 and 25 and, is that right? 5 and 9 and 15 and 35. Yeah, it's 39. So 39, what did I just say? 9 and 15 and 25 and 39. Yeah, okay. 39 divided by 6, that's equal to 6.5. So 6.5 is our mean. Now let me go back to what I said before. If I see that the median and the mean are not the same, then that means it's skewed in one direction or another. Okay, so if we've got a median of 5 and a mean of 6.5, that means the mean is a little higher. That means it is skewed right, just by looking at these two values here. Okay. By the way, another little side note here, with symmetrical data, the mean equals the median. We spent a lot of time on all that. The mode is the most frequently occurring item in the sample. Now you can have more than one. It can be more than one. Can be more than one, and or none. Okay, we'll look at an example of each of those here in a second. But you can have more than one mode, or you can have no mode. In fact, in this case here, there's nothing that repeats itself. So the mode, there would be no mode. And the range, the last thing here, it's a long video, sorry. The range is, it's the distance from the lowest to the highest, and what you can do is simply, if they're arranged in order, take the maximum value minus the minimum value. So in this case, the range is 12.